Okay, here we have page 2 of the notes. Scarlett is going to invest 7,900 and leave it in an account for 18 years. Assuming the interest is compounded continuously, so continuous compound formula is what we're going to go with. What interest rate to the nearest 1/10 of a percent would be required in order for Scarlett to end up with $12,300? So we're investing 7,900. Times base E raised. Here we don't know the rate, so that would be variable R. We know that it's going to be in the account for 18 years, so that's our time. And we want to accrue a total of 12,300. Okay, so here we're going to want to isolate base E raised to the R times 18. So divide both sides by 7,900 first. Now we can convert to natural logarithmic form. So ln base E and in order to solve for R, we would now need to divide both sides by 18. Now, reminder, the E here, you really won't see that when you're doing ln, so it's really no longer necessary. We don't need that. We're just going to plug this portion right here into your calculator. Oops, let me start with the fraction symbol. On top of that fraction, we have ln of all right, so we have R equals 0.0245 9. I'm going to stop there. Now rate, we're going to list that as a percentage. So move the decimal spot over twice. So 2.459%. And what are we rounding to? The nearest 10th, which would be here. So this would round to 2.5%. Final answer. Example 8, Carter is going to invest $210 and leave it in an account for 5 years. Assuming the interest is compounded annually. There's our key word there. So we're just dealing with compound interest here. What interest rate to the nearest 1/10 of a percent would be required in order for Carter to end up with $250? So start with the initial investment. Now, look at how this changes when we're compounding annually. I'm going to skip a couple of things. Okay, the rates here, that's what we're solving for, isn't it? What rate? Yes, so we don't know the rate. Now, you could do R over 1 because since we are compounding annually, that's what it would look like, R over 1. But I'm not going to do that because R divided by 1 is just R. Let's see here. And there's 10% will be required in order for Carter to end up with $250. That's not helping me. Okay, here we go. 5 years. We're leaving it in for 5 years. Now we normally do the amount of times compounding 1 times the amount of years. But 1 times 5 is just 5. So when you're compounding annually, you can simplify ahead of time. And we know that we want to accrue a final amount of $250. So we want to isolate the parentheses and the exponent first. So divide both sides by 210. Now, we haven't seen one like this, but we've solved stuff like this before, just a long time ago in algebra 2. In order to eliminate any power, you can take the root of that power, if you will. So here's what I mean. Since we are dealing with the fifth power, we are going to take the fifth root of both sides. That'll leave us with 1 r is equal to the fifth root, 250 over 210. Now, in order to get r by itself, just subtract 1 from both sides. R equals fifth root of 250 over 210, and then minus 1 outside of the root. And now we're going to plug this into our calculator, exactly how I have it written down. In order to take the root of any number, you're going to hit the math button. And then on my calculator, it's option 5. Has a little X where you would see the 5 in my example here. Now, for some reason, it says answer there, so I'm going to scroll over and put 5. We're putting the fifth root in its place. Inside that root, I want 250 over 210. And then make sure you're outside of the root now and do minus 1. So R 0.035548. That should be plenty. Let's move that decimal place over twice. And then let's go back and see, where are we rounding to? Once again, to the nearest tenth, which would be 3.5%. Final answer. William invested $2,300 in an account paying an interest rate of 2 and 1/8% compounded quarterly. What is 2 to 1/8%? If you don't know what 1/8 is, here's how you can figure it out. 1/8, that's a division problem. So in your calculator, do 1 divided by. You get 0.125. So 2.125%. Nolan invested $2,300 in an account paying an interest rate of 2 to 3/4% compounded monthly. So same thing there. If you didn't know what 3/4 was as a decimal, you could do 3 divided by 4, which is 0.75. Okay. After 20 years, how much more money would Nolan have in his account than William, to the nearest dollar? Now let's look for some keywords here. Compounded quarterly, compounded monthly. So we're going to have to set up 2 equations here, but both of these equations we will be using compound interest formula. So let's start with Will. He's investing $2,300. Now, I already gave you that percentage a little bit earlier for Will. If we convert that to a decimal, it would be 0.02125 over the amount of time for compounding. Nolan is compounding quarterly. Raised the amount of time we are compounding times time after 20 years. Okay, plug that in your calculator and get the answer. I'm going to go ahead and start setting up what Nolan's data would look like. So Nolan is going to invest also $2,300. That rate for Nolan, once again, was 2.75%, so that'd be 0.0275 over, how much is he compounding? Nolan is compounding monthly, so that'd be 12. Raised to the amount of times we're compounding times time. Should be 20 years. Okay, so now you have the data for both Nolan and Will. You would need to enter that data into your calculator and then take Nolan's amount and subtract Will's amount. Whatever you get, make sure to round to the nearest dollar. Pause the video and then you'll see the answer when you're ready. For a final answer of $470. Listen to how generic 10 is. A person invested $1,500. I kind of like it though. But anyway, let's see what we're doing here. A person invested $1,500 in an account growing at a rate, allowing the money to double. Whoa, we haven't seen that yet. Every 12 years. How much money would be in the account after 15 years? We're going back to the first video. I showed you a list of formulas that we would be using. Since they're using the word double there, we would need to use double time growth formula. That's what we'll be using for this one. Remember, you're going to need to know the key words so that you can identify what formula to solve a particular problem. Okay, so a person invested $1,500. This random individual. We're going to start with the initial investment. We'll go ahead and create a fraction here. Now we're dealing with 2 bits of time here. On the bottom is going to be the amount of time that it takes to double. So this money is going to double every 12 years. So 12 goes on the bottom. Up top is the amount of years that we're solving for. So how much money would be in the account after 15 years? We don't know. But if you plug this into your calculator, you'll get the answer. If you entered that data incorrectly, you should get $3,568. Okay, question 11, element X. Whoa, they're still being incredibly vague. Whatever. Element X is a radioactive isotope such that every 26 years, its mass decreases by half. Ooh, there's a key word. Half-life. Given that the initial mass of a sampled element X is 680 grams, how much of the element would remain after 19 years to the nearest whole number? So let's start with the initial amount of element X. Okay, now this fraction here is going to consist of 2 amounts of time. On the bottom is going to be how long it takes to half. Which, what do they say? Every 26 years, its mass decreases by half. So every 26 years, it's halved. So that 26 is going to go to the bottom of the fraction. How much of the element would remain after 9 years? We're solving for after 19 years. I think I said 9, I'm at 19. So that's going to go on top. We now know everything to plug into our calculator to find the answer. Try that. You should get 410. Well, a new pair is purchased for $26,000. And over time, its value depreciates by 1/2. Keyword. So half-life every 5 years. How long to the nearest 10th of a year would it take for the value of the car to be $2,300? So we're solving for variable T here. The initial purchase price of the car times 1/2 raised. We're solving for T. We don't know how long it's going to take. But we do know how long it takes for it to depreciate by half. It depreciates what's wrong? I can't say that word. It depreciates by 1/2 every 5 years. So put 5 there. And we're solving for once it depreciates to 2,300. Okay, so we need to isolate our base and our exponent. So first thing, divide both sides by 26,000. I'm going to go ahead and convert 1/2 to 0.5. Now we can convert to logarithmic. Now, in order to solve for t, what we would have to do is multiply both sides of the equation by 5. When we do that, make sure to surround this entire portion in its own set of parentheses, and then multiply it by 5 outside of the parentheses. And by doing that, we will solve for t. So we're going to plug this into our calculator. So make sure your calculator looks like mine here. Enter. We're rounding to the nearest 10th. So it's going to take about 17.5 years.